we should be live. Dang it, I'm a minute late too. For some reason YouTube just wasn't letting me click that live button until I refreshed the page a few times, but we made it. So we've got ourselves 3 HomePods that have showed up today for repairs. First 2 will be no power, and then we'll move on to a HomePod with death farts. So let's go ahead and jump right into it here. Haven't quite fully opened these up yet. Yes, there we go. Their first HomePod is free. Free from its bubble wrap coils. Let's go ahead and plug it into some power and double check our symptoms here. So, seeing no response. And we're getting about 3 watts of power draw. So a little on the high side if it's a short on the logic board, and a little on the low side if it's a short on the amplifier. But let's go ahead and crack it open and check the usual suspects and see what we've got going on inside here. Oh, that's sad. It looks like the top on this one has a tiny little crack on there. That's sad. I wish we were able to buy replacement ones of these. I'd be more than happy to replace these for people, but unfortunately, as you can imagine, these in good quality condition used are getting harder and harder to come by. Something that I unfortunately don't have any more of. I wonder how we could, it'd be a pretty simple part for me to whip up in like SolidWorks or something, but I wonder who I would contact in order to actually get like replicas of these made. Because I'd be interested in that. I'm sure many people would be interested in a replacement top touch cover here, even if it wasn't like an exact replica. You know, there's people out there with these that are really beat up and cracked or totally missing, and I'm sure any kind of replacement is better than what they've got now. So maybe one of you guys knows someone or somewhere that I could send some 3D design files to. If I were able to just whip one of these up, maybe somebody can manufacture some. Or maybe I can just send them one of these and they can do it. They can do all that for me. That'd be cool. There we go. It's not often this adhesive here sticks to the display. Usually it sticks to this plastic frame here. But I just wanted to get that all stuck back on there, lined up decently, so when we go to put this back on, we won't have to fight with it. Before we go much farther, I just want to make sure that it's not their logic board on this one that's causing their no power here, because we did see a slightly lower amp draw or power draw from the wall than we usually see with a short on the amplifier. So we've got a known good logic board connected there. Let's get that plugged in. And yep, same thing, no power. Okay. So probably a short on the amplifier. Let's continue with our disassembly here. My bit here, the little spinny top on here, is starting to feel kind of gritty. I don't like that. How do I fix the iFixit screwdriver? Ooh, that feels terrible. Yuck. Still spins just fine, but as soon as you push down and spin on it, it feels nitty gritty. Huh. Have we finally fixed so many HomePods with this thing that it's started to really wear down? We counted the other day how many diodes we have in our dead parts pile over there, and we made an educated guess based on that. About 205 HomePods roundabout have been through here and fixed by me so far. Which is, when I think back about it, that's a lot of HomePods. Doesn't feel like I've been doing this for almost a year now. And we can hit it with another round of pry. Yeah, there we go. That should do the trick. This might be an off the desk peel here. Oh, maybe not. No, I'm gonna have to do this off the desk. Hey. Hey. We did it. We got him. Comes the woofer. Let's see. Voice coil looks alright. Feels alright. And smells fine. So that's a good woofer there. We've got our primary suspect out. Let's get up close and just do a quick diagnostic here and verify our suspicions. So we've got a date code on there of 1746K. It doesn't look too worn out, but looks can be deceiving. Yes, indeed. That diode is shorted out. Let's get our stuff turned on here and pull that bad boy off. There she goes. Stick that in our bad diode pile over there for now. And let's get ourselves a brand new one. Prep that up for the board. Alright. Very nice. Let's cool this off real quick. Get this put back together and test it. See if we can power on now. And while we're at it, we'll check it for any DC offset before we put it all back together. Welcome folks to the stream. Just to catch you guys up, we are currently working on HomePod number 1. We've already got it torn down to the amplifier here. Found the usual, a shorted Schottky barrier diode on the board right there. Same one as usual for these no power repairs. And it feels cool enough for us to go ahead and put it together for a test. So let's go on and do that. There go my tweezers. And then let's get our multimeter in here. Alright, we've got a good connection to the subwoofer for our multimeter here, so we can check it for any DC offset issues. Let's see if it powers on. Yeah! Of course it powers on. Alright, now that it's powered on, we need to trigger the amplifier on. So let's go ahead and do that. And geez. Alright, 65 millivolts of DC offset bias and quickly growing. So it seems like this is also going to need some new filtering capacitors. If we were to just ignore this, it would probably work fine for a few minutes, heck, maybe even a few hours. But eventually that will grow into a problem. And if it won't cook your subwoofer, it will cook your amplifier. And if it doesn't do either of those, you're going to get death farts. So let's go ahead and get those filtering capacitors replaced. See if we can't prevent that from happening. The goal, as usual, will be after we replace those filtering capacitors, we shouldn't see more than 50 millivolts of DC offset on that multimeter there. That is the target. And there they are. Alright. Got those old nasty caps off. Let's chuck those in the dead pile. There's unfortunately no great way to, at least to my knowledge, to really test which one of these are bad. Even then, a lot of testing methods can show that a component is good, but it ends up actually failing under load or only certain conditions. So our idea here is to just go ahead and replace all 4 of them while we've got it and while we're doing it. I mean, if one of them failed, you've got possibly a 1 in 4 chance of any one of them failing. I mean, you've got 4 chances of those. What am I saying here? Am I that bad with numbers? Well, I mean, you've got 4 of them here, and if one of them goes bad, that's already kind of crappy chances you got there, and you got 3 other ones there just sitting waiting to get worse and cause more issues. Alright, enough yapping. Let's touch these pads up with some fresh solder. Cool, that was too easy. Let's grab some new capacitors from our parts pile here. If you want to know what parts I use for my repairs, I've got all that information on my website at nixfix.com. Just go down to the common issues section and find your issue, and I'll have the part numbers that I use for my repairs listed there along with it. If I wanted to be like a turbo pro at this, what I should do with these capacitors, the new ones, is I should have them on a hot plate, preheated. And I think I might find myself one of those and do that. Oh, there it goes. Get back here. And there you go. Let's give those a little more flex and a little more heat one more time just to make sure they're nice and on there solid. Okay. Let's cool this board down, because of course heat will impact these capacitors' ability to filter that DC. So if we just replace those capacitors with a bunch of heat and then immediately go and test it, we're going to see a bunch of DC getting through. So we want to let this cool down, and then we will test it again. There you go, little guy. should be good enough. Oh yeah. Let's test it out. Is it? Okay. That's reading all right. Here we go, round 2. Alright, and the verdict. Look at that. Perfect. Perfect. 4 millivolts. It'll probably settle down at around 0 to 1 millivolts. Goodness, that's a good result. Anything below 50 really is considered fine. Anything below 10 millivolts is what I call the perfect score. So 4 is great. This is ready for reassembly. Oh, interesting. I think I might have figured out how people keep breaking these microphone boards here. And I think I've got an example of one of those here somewhere. Where did it go? Here we are. So, on these microphone boards that are mounted right here, I've had an oddly large number of requests for this specific part. And all of them seem to have this chip right here broken off. And every time I ask people, like, why, how did this happen? Nobody's ever given me an answer. And I think I might have figured out how that happens and kind of why nobody actually has told me. So when they probably go and put the screw right on the amplifier right back here in, their screwdriver is they're probably pushing it up against the amplifier board in there like this, and probably breaking that chip off while they're putting that screw in, or maybe while they're taking the screw out. I've honestly never noticed that or had that problem before, because I pretty much put all these screws in with my screwdriver at an angle. And funny enough, that's not any sort of like best practice or like anything that there's no real reason that I do that other than so you guys can see where I'm putting the screws in. You know, if I put the screws in straight from the top like this, it's a lot harder for you to see what I'm doing. So I try to do it at an angle like this so you can actually see where the screw's going in. And I think that's what's probably been keeping me from figuring that one out for quite a long time. But I think and of course if, you know, you accidentally damage this, being a doofus when you're unscrewing it and you break it off that board there, of course you're not going to tell me why. That makes sense. I mean, we're all doofuses though. I've made doofus mistakes myself. But I was talking to a coworker about this earlier today too. I'm fine with mistakes. Mistakes are an opportunity to learn things. And he said, that's right, because you don't learn anything if you do it right the first time. Took me quite a few HomePods fixing for myself before I felt confident enough in offering it for other people. I've definitely broken a few of my own during my earlier attempts, and I've certainly broken bits and pieces here and there when I started fixing other people's at the start. But start getting a feel for the way certain parts can come apart, how you can slice them and dice them. It only comes with practice and time. I'm not saying you can't take apart your first HomePod without breaking anything. Totally doable, especially with all of the information that's out there now. And it's a lot easier with what we know now to take these apart without breaking them. It took me like an hour or so on my very first HomePod just to get the dang touch and display thing off there. I was so worried about breaking it. But in my mind, I just kept going because at that point I didn't really have much to lose. It was already broken. Get out of here. Nice. Sounds nice and sealed. Let's go. Oh, looks like we got a little bit of adhesive covering that volume button there. We'll just clear that off. Don't want that making our volume buttons look funny. There we go. Give it a little bit of heat to revive that adhesive there, make it stick nice and good. Not too much heat though. You can very easily hurt your parts here. So that's why I'm holding this one, so I get a general idea how hot I'm getting these. If it's too hot for me to hold, then it's probably fast approaching too hot for the plastic part itself. And then since there's a crack right there, we want to be a little careful when we're pushing this back down around that area. We don't want to make that bigger. All right. Did a good job there. Let's plug this into some power and do some sanity checks here, and then we'll move on to the next HomePod. Drum roll, please. Yeah. All right.
I'm having trouble connecting to the internet. For more info.
Very nice.
I'm having trouble.
And volume buttons are nice and evenly lit. So this one's ready to go. We'll set that to the side. And let's grab their second HomePod here. Here we go. See if this one's got any cracks on it we need to be careful about. No, this one looks all right. A little dirty, but we can clean that up easy peasy. Let's check it out. All right, no signs of life. And that's a little more what I expect there, about 4 to 5 watts being pulled at the wall, so that's most likely same thing as the last one. We've probably got a shorted diode in here. Let's crack it open and find out. Very nice. guys can hear that scratchiness, right? That's the screwdriver. I do not like that. Maybe I can spruce up a few iFixit articles on the HomePod here, and then ask them for a replacement. Ugh. Wow, that's really stuck in there, isn't it? Is this one going to do the same thing as the other one with the adhesive? Huh? No, it's not. It almost did. Almost. There we go. Oof. Oh, didn't see your chat there. Welcome to the stream, Andy. Time for the pry. Ooh, that one's coming up nice. Alright, let's see if that'll come apart. Very nice. Also, these are yours, Andy. All right, nice. Glad you could join us and watch them get fixed live here. And I'm just happy to be here, alive enough to fix some HomePods. I mean, I've got a few other things going on in my life at the moment, but I won't share any details. But really, couldn't ask for much more now. Well, if Apple wants to pay me to fix HomePods for them, that would be nice too. Actually, maybe not, because part of the reason why I like doing this all on my own, and part of the reason why I do this in the first place, is, and the reason in how I charge how much I do for these repairs, is because I wanted an option for people that was more affordable than going to Apple and paying them for an out-of-warranty replacement. So it's like, there's repair shops out there that'll be more than happy to fix your HomePod for the same price that Apple will charge you to replace it. But I don't know why that is. To me, honestly, these are like not that difficult to take apart. I really do enjoy it. So am I an artist? I wish I was. I feel like I've got the imagination of an artist, but I don't have the patience or the skills to actually put it down onto paper or actual musical form, if you know what I mean. What gave you the idea that I'm an artist? a closer look at that. One's 1746K on that diode, same as the other HomePod. And it's probably going to be shorted just like the other one, too. Yep, yes it is. Let's get that replaced. Oh, my fingernails. My wife does my fingernails. She's actually a nail artist. And whenever she gives me a manicure, I ask her to paint my nails like bus seats. 90s bus seats. And I think she didn't do a half-bad job. And by that I mean the work itself was perfect, but I've put these through quite a bit of torture, and they've been on for a few weeks and they still don't look half bad. You should see them when they're brand new. They look freaking incredible, but they are absolutely beat up now, so. But for taking apart a few dozen HomePods over the course of a few weeks, they're holding up pretty well. How many HomePods do I fix a week? On average, I get 2 to 4 every day, I'd say. So probably, yeah, about 10 to 20 a week. And even then, that can fluctuate. Like a few days, I'll have like, there was that one day I had 6. I think that's the most I've had come in one day. When I was first doing this almost a year ago, it was only 1 or 2 every few days. But once word started getting around, and I don't know, presumably more people's HomePods maybe started breaking too, they were looking for options, and they find me. And we've got the past few months have been a pretty steady rate of like 2 to 4 a day. There we go. Yeah, we counted how many dead diodes we've kept from all of the repairs. Unfortunately, I didn't keep the first 20 to 50 of them, so add an extra 20 to 50 on top of the ones that I have kept and have. But just from no power repairs alone, I've got 130 dead diodes, all from the same failure. So at least 130 HomePods, if not around 150 to 170 that have come through here for just the same exact no power repair. Aside from that, there have been about 30 to 50 that have come in for other repairs, so completely unrelated to no power. So quite this statistic. Unfortunately, Apple has probably taken the lives of many, 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 many more broken HomePods from people before I was able to start getting the word out. And even more unfortunately, I doubt they do any sort of diagnostics on them beyond plugging it in, seeing it doesn't work, and then giving it to old Daisy to get disassembled and broken down to its raw recyclable materials. And realistically, only Apple would be the company or person, place, or thing who would ever really know what's going on here. At least until they tell us or give us schematics, or that's never going to happen. I don't know if the iPhone quality is way better. I'm not so sure about that. They've all got their issues of their own. They didn't do a very good aging test, I guess. That could be one thing. You gotta think though, when was the first ever HomePod no power failure from this issue? And then think how long it took for that to happen after it was released. How long would you expect a company to do long-term age testing on a product before you would allow them to sell it? What's more likely is this diode may not have the it may just not be up to the task for what they put it in here for, just plain and simple. What's more likely, in my opinion, so based on all of the dead diodes that I have, and based on all of the other diodes that I've taken from people's HomePods, whenever a HomePod comes in for repair, whether it's no power or anything else, I always replace the diode while we have it. So that actually gives me a little bit of a picture here as to there's a date code on the actual diode, and for some reason all of the dead ones have the same date code of 1746K or 1748K. All the used ones that I've pulled off of everyone else's HomePods for, that powered on fine, they're not shorted out, they just got replaced preemptively. They all have different date codes. Some of them still have 1746 or 1748K and they were still working, but I went ahead and replaced them irregardless. And yeah. So to me, just based on what I have, the information that I have, is it would seem that there was a bad batch of these diodes manufactured. And from what I can see, Apple's used these diodes like across many different dates. I don't know exactly how many of each date of diode is used in each HomePod. So I don't know if this is a valid correlation, i.e., there's a specific date range of diodes that were poorly manufactured and have quality issues, or if the diode itself is not suited for this task, or there may be something else entirely going on here. Unfortunately, at this time, I'm not quite smart enough yet to make a full... Oh, hold on here. We're getting ahead of ourselves. Let's get this plugged in. And that's another thing. A lot of people claim that it suddenly stops powering on and this happens to them after an update. And I don't know what to make of that, because I see that would be strange. What would the software be doing to this power circuit right here that would cause it to short a 60 volt 5 amp Schottky barrier diode? It's very interesting. I see a little bit of a bridge in there, so we're gonna get that too. There we go. And yeah, it's powering on. So the diode itself, all of the diodes come from the same manufacturer. So, but yes, they have various different manufacturers supplying different parts for this HomePod. But I think that's how most things are, right? All right, so this one looks like it's also going to need some new filtering capacitors as well. All right, no big deal. What's probably most likely the thing here is Apple intentionally designed this thing to only last a few years. Because when you think about it, the capacitors back here that are supposed to filter the DC before it goes through the amp and into the woofer, when these go bad, that's what causes your death farts. That's what fries the amp IC. That's what fries the subwoofer. The very nature of these capacitors is for them to lose their effectiveness, their capacitance over time. So why they would use these, unless I'm misunderstanding something, use something that they pretty much know is only going to last for a few years before it starts to fall out of spec enough to cause drastic failures. Who knows? I'd really love to pick the brains of the Apple hardware engineers that designed this thing. Because for all we know, there are perfectly logical explanations for all of this, and well, if anybody's gonna have it, we know Apple's gonna have it. Have an answer. They have an answer for every issue, apparently. Usually they say it's user error. But if that's the case, why didn't you say so sooner then? Overheating because of a software glitch? Maybe. I can't say that's an impossibility. I never really considered that. It sucks that nobody's actually caught that before it shorts the diode then. Because I'd be curious to see if the software successfully updates or if it fails and it's reverted to the previous version. Yeah, well, I won't say Apple is evil, but Apple might be evil. Just a little. I mean, look at like hold on. Let me touch up these pads. If I talk while I try to do this, I'm gonna mess something up. Beautiful. Oh, okay. So that's, yeah, I've been meaning to ask you that. They broke at the exact same time? That's huh. That really racks my brain. Were they on 15.6 and you were updating them to OS 16, or were they on was it an older version? I can check too when we get this other one powered up. If you want, I can factory reset it and check. Oh, you might have said this in your email too. Alright, let's see if this one's all ready to go. Oh, I think your home app, even if they're not online at the moment, I think the home app will even tell you what version they're on. They were broken around 15.1 something. Okay. Huh. Alright, let's see if this is all ready to go. Alright. Yeah. Come on, go down to 10. You know you wanna. You know you wanna. I'm sure if we let it cool down all the way to room temperature, waited about 24 hours, we'd probably see flat 0. But this is what we want to see here. That's all good to go. I'm glad we checked that, because had we been any other repair shop and didn't know better, we would have just gone in there, fixed your no power issue, charged you out the ass, and then sent you on your merry way. And a few hours, days, weeks, maybe even months, it would work fine before you would suddenly start having death farts and other sort of base issues here. So I'm really glad that we do this DC offset check with all of our repairs, because that's definitely saving a lot of HomePods from well, I mean, not just coming back to me to get fixed again, but I mean, that also wastes a lot of resources. I mean, you imagine shipping things back and forth twice, the time wasted, you know, the time you could be spending enjoying the thing. I'm glad we were able to solve that. That's what really got me into the HomePod repairs. Was I saw the challenge that no one had solved yet, which was the death farts and the DC offset pops and all that. No bass. And the only solution anybody could come up with at the time was, I'll just replace the amplifier with another one. And that wasn't good enough for me. I wanted to crack that nut. And, well, we figured it out. So, I will brag about that till the day I die. Hell, I'll put that on my tombstone. Here lies the guy that fixed the death farts. And honestly, I could care less if more repair shops start picking up on these and offering repair services, hopefully even at competitive prices too, because I want people to have options. Something might happen to me, and well, it would be nice if as much as I enjoy doing these repairs, if I had more competition, obviously I'd have fewer coming in for all these issues, and I might have more time exploring more things here. But that doesn't go without saying, I am perfectly content for the time being doing these repairs. And honestly, like, it can't stay like this forever. There's a finite number of HomePods that are going to break and that people are going to want to get fixed. So eventually, eventually, we'll end up finding ourselves moving on to other things. But my love for the HomePod will never die. Well, that is until Apple or somebody else produces something that's objectively matches or exceeds the specifications and performance of one of these speakers. That'll be the day that I probably end up selling all of mine and replacing them all with whatever that is, assuming it's designed any better. A HomePod shaped tombstone. And in like 50 to 100, oh hell, maybe even 20 years from now, people are going to be wondering, what the hell is a HomePod? We're going to have to go back and look at Apple's product history and go, oh. Or maybe Apple will continue the HomePod name for quite some time. I don't ever find myself or see myself ever doing repairs on the minis because, I mean, it's so little, it's so small. It's like, how do you charge for repairs for something this small and cheap? Like, you can buy these used for about as much as I would be able to economically charge for repairing one of them. So, Apple nailed it there, I guess. That's what I like a lot about the HomePod, is it's not just a Bluetooth speaker. Sure, you can't use it as a Bluetooth speaker. That may be an inconvenience to some. But to me, I see that as a huge plus, because instead of using Bluetooth, it's using AirPlay, it's using Wi-Fi. It can, in theory, stream any quality audio that you could come up with. Granted, they only support up to, such a high quality, but it's far better than Bluetooth could ever be. At least from what I can see anytime in the near future as far as Bluetooth is concerned. I hate Bluetooth. Everything that I use that uses Bluetooth sucks as far as experience goes. Yeah, but don't get me wrong, I love my minis. They've definitely got their place. I've got one at my desk at my office, and because I don't want to waste a full-sized HomePod sitting at my office desk for when I'm barely there. But when I am there and when I want to listen to music at my desk, the mini is absolutely perfect for that, because it's not too loud. Like, I don't have to have it turned up so loud that it's bothering anybody in other cubes. But in my cubicle, it sounds nice and full, and it's perfect. Absolutely perfect for something like that for me. Also for, like, the garage or the bathroom, places where I wouldn't really feel so comfortable placing, a $200 to $300 speaker in, at the risk of it being stolen or water damaged or whatever. The mini just fits in a lot of really good spots. I like it. And it's like, for the size, again, like, is there a better sounding speaker for this price and size? That I don't know. I do know that the full-sized HomePod, I will say, in my opinion, It's got everything else beat. But I don't know if there's a comparison for the Mini. Hey, Eddie made it to the stream. How's it going, man? You're probably at work right now, aren't you? Lunchtime. Nice. Echo Studio just being released. See, I already feel I'm personally pushing my privacy boundaries having the HomePods all over my house. I don't know if I could get over having an Alexa or Amazon device always listening to me as well. I and I'm sure this is true for most people, but if I'm gonna give my personal data up and my privacy up, I trust Apple more than Amazon. Not that I fully trust Apple either, but I trust them more than Amazon, for sure. But if the sound quality and the performance and, like, you know, the 360 sound, if they can prove that it would be objectively better, I would buy a few, physically cut the microphones out maybe, and live with it. I'd lose voice control, but I care more about just playing music back from my tablet or phone than yelling at my speaker. Damn, Eddie throwing the shade right out there. Apple didn't offer anything new. That seems to be the common opinion here. Like, iPhone pre-orders apparently aren't doing as hot compared to their previous models, which is again another trend that seems to be the case with them. Every time they put out a new phone, it seems to be getting less orders than the one before it. And that seems to be mostly true for the majority of the smartphone market. I mean, you've probably heard it a million times, but, like, most smartphones seem to just be, like, stagnating with only incremental improvements. And it's giving people less and less of a reason to upgrade their 2 to 4 year old smartphone, because their 2 to 4 year old smartphone is perfectly fine for most things that people do. I'm still rocking. So I've got two phones that I daily carry. I've got my work phone and my personal phone. My work phone that they pay for, that's an iPhone 12 Pro Max. But my personal phone, the one that I pay for, I've still got my Note 10 Plus, And it works just fine for everything I need to do with it. I'm not super happy with the camera quality on it. The last time I was happy with the camera quality with a Samsung phone was my Galaxy S6. Ever since then, I don't really like the direction that most smartphone cameras have been going with the whole depth of field and bokeh and it's also had a nasty impact on like how like up close shots for me too. But supposedly the iPhone 14 Pro's cameras are exactly what I'm looking for. The AirPods Pro 2. Now, that makes me salty because I feel like it's totally possible for them to implement half of the features that I want from the 2s on the original AirPods Pros. Did I really not put 2 of those subwoofer screws back in? This is what I get for talking. Talking and fixing at the same time. I respectfully disagree with you, sir. Android, like many things in my opinion, certainly has its place in many common people's hands. I mean, first of all, for the folks, and this is the age-old debate, right? Of like, Android has more customization, iPhone has more unlock it and just use the damn thing capability and the attention to detail. That comes with a hardware company that also makes the same software for it. But when it comes to customization and the availability of apps and things that I'm looking to do with my phone as like a multi-tool kind of device, my Android phone kicks my iPhone's ass. And then I also look at it from a software developer's perspective. Having just a little bit of experience testing and developing iOS and Android applications, Android has far more freedom to do what you want to do with your device than iOS. It again goes back to like, what do you really want out of your phone? Do you want more, do you want a more uniform, one-size-fits-all user experience that's more likely to work for most things? Or do you want something that needs a little more attention from you, a little more work and effort put in from your side, but with more freedom in turn? And I mean, I would flip-flop. Personally, if I only could choose and carry one phone, I don't honestly know if I could. First of all, because there's just too much that I do that I can only do on one or the other. But aside from that, like if I had to choose only one, I would honestly be switching between one or the other every other year. Just because I like to taste it all. Hey, have a good one, Eddie. Thanks for dropping by. Yeah, glad I'm not a real doctor. No kidding. I choose patients that I can fix without, you know, killing them if I make a mistake or two along the way. Props to doctors, though. Keep up the good work, guys. That's the thing. You got it, Andy. You once you go Apple, you never go back, and like, there's a lot of things like if I okay, fine, I'll say it. If I was on a desert island stranded for the rest of my life and I could choose between one or the other, I can't. I can't. I can't answer that. Cause like I keep thinking about how nice Discord is on my iPhone. But then I turn around and think of what I could do to survive with my Android phone. Well, I actually I have to take that back because the the iPhone 14 Pro's got that the satellite shit in it now. So they've they got me there. If you go with T-Mobile, you can use their satellite service as well. No kidding. That's who I use for my personal line is T-Mobile. I did not know that. Do you need a phone that's got the physical hardware capable of doing that too, or can you do it with pretty much like any regular like smartphone? Oh, yeah, Starlink. Okay, yeah. Did not realize that though. Yeah, I did notice that T-Mobile does have bad signals indoors sometimes. I don't have a problem with it at my house. But God forbid I find myself in the middle of any like store and I need to look anything up. Actually, now that I think about it, every time I've found myself without service with my T-Mobile phone, I've had pretty crappy service on my AT&T phone too. But I mean, these days, how many cell towers are just renting the same physical tower to all of the different cell providers, and they're all basically just using the same backhaul at this point. I don't know too much. I got a friend that knows a lot more about that than I do. The world was not ready for 5G. Because, like, with every iteration of new, like, cellular signal service, like 3G to 4G, 4G LTE, 5G, each increment, sure, it may have increased the bandwidth available, like the how much bandwidth you can shove through that spectrum, but it comes at the cost of range. Because they're running at higher and higher and higher frequencies with each new iteration, those higher radio frequencies don't penetrate through things as well as lower frequencies do. It's the same with sound, if you haven't noticed. You normally hear the rumbling of a bass coming through objects better than you hear the higher pitched noises. And that's a great example to help understand why things like cell signal and Wi-Fi 2, 2.4 gigahertz Wi-Fi has a much better range and penetration ability than 5 gigahertz Wi-Fi, because 2.4 has a larger wavelength. But it comes at the cost of speed, of bandwidth. So it's all a trade-off. And when they pushed 5G, well, I mean, I feel like they still didn't really have enough towers for it to get very great coverage comparable to 4G before they got 4G up to when it was comparable to 3G. Yeah, and 6G's already on its way. I'm sure they're already past that and they're already drafting 7G. Spot on. I couldn't agree more. 4G LTE is all I could really ask for in terms of speed, signal, and just, yeah. And on most mobile devices where you would be using that cell service, like you've effectively only got a 1080p screen to look at anyways. Anything above that's going to be barely noticeable to most people. Okay. Let's supply some power. Do some sanity checks. Drum roll, please. Yeah. And it looks like we got some stainage on the top there. Let's go ahead and clean that off here real fast. We're just gonna get a microfiber cloth. Some rubbing alcohol on there.
I'm having trouble.
I'm sure you
I'm
are,
having
buddy.
trouble connecting to the internet.
I'm sure
For
you
more
are.
info, check the Home app. I'm having trouble connecting to the internet.
All right. Well, we know it's powered on, and
I'm having trouble connecting to the internet.
I get
For more
you.
info, check the Home app.
Bass sounds nice. Let's see if the volume buttons light up nice and even. Yes, they do. All right. We got both of them fixed. So Andy asked, what is death farts? So death farts are basically, it sounds like this, like a bass, like you know what a bass drop is in like dance music. It sounds like your HomePod does a big fat bass drop, and then it crashes and restarts itself. The reason why it does that, and we actually did the repairs on your HomePods because we saw early signs of that happening on yours as well. The reason why that happens is those filtering capacitors on the back of the amplifier, they love to go bad over time or fail for whatever reason. So they start to allow more and more DC voltage through the amplifier and into your subwoofer speaker. When that DC voltage grows beyond a certain point, that's when it causes your HomePod to trigger that death fart and forced restart behavior. So that's why after all of our repairs here, you see me take the amplifier from the HomePod and plug a subwoofer into it with a multimeter, and we check the DC voltage reading that the amplifier is putting into the woofer, because that will give us an idea of the condition of those filtering capacitors, and thus reasonably tell whether or not the HomePod's about to start suffering from the symptoms of that, i.e. death farts. And it also comes along with other issues like really loud popping as it goes in and out of standby, crackling in the bass. It can kill your subwoofer, and it can kill the amplifier chip itself on the amplifier board that powers the subwoofer. So it's pretty nasty issue. It's preventable, but usually you don't know until it starts actually farting that it's gotten that bad. Okay. So let's get this one opened up, and maybe we'll reproduce a death fart here on stream. Ooh, Eddie. Oops. Okay. Eddie, my guy, that is a nice case. He showed me this HomePod case that he found on Amazon. Wow. Alright, I might have to buy myself a few of these, because it gives you a place to put the power cable separate from the mesh here with no chance of it like rubbing into it and freaking causing like dents and imperfections in your mesh here. That is nice. Yeah, this is actually the guy that was just in the chat earlier. His name's Eddie, and it seems like he travels with his HomePods. So this is an excellent solution for lugging these things around. And it's even got a handle on it, and like there's that's really nice. Okay. Here's our pod. So let's plug it into power and see what we've got here. And while that's booting up, let's go ahead and update our text up there on the screen. There we go. Okay, so Eddie told us that this HomePod has death farts. So, you know, based on that, blah, 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 DC offset, DC's getting into the woofer. I'm willing to bet when we wake this up, we're going to hear a pretty healthy pop. And we can kind of judge how much DC offset it's experiencing based on how loud that popping sound is. So let's take a listen here.
I'm having trouble connecting.
Oh, actually, I didn't hear any popping. What about when we unplug it from power? Oh, okay. Let's check that one more time here. It was strange I didn't hear it popping the first time. It must have done it while I was talking. Yeah, that's a pretty nasty pop. So I'm gonna guess, you know, based on how loud that is, that popping, it's probably got like 600, 700 millivolts of DC offset, which is very, very bad. It's essentially, basically, you're taking a 9-volt battery and sticking it on your woofer here, and if you look at this woofer, watch what happens to it when I put a battery to it, when I apply DC voltage to it. Sound familiar? That is why you don't want DC on your speakers, because it pushes that speaker in one direction and it holds it there, and that can wreak all sorts of havoc on your parts. So that's why you hear that popping sound when these capacitors go bad. They start to allow more and more DC voltage through to your speaker, resulting in that popping sound. Eventually it gets so bad it'll fart. So my guess is we've got 600 to 700 millivolts, and it'll probably, within like 10 seconds of having it powered on, it'll probably creep up to 800 to 900 millivolts. Death farts seem to occur when it gets to about 2.5 to 3 volts. And the reason why it may start with 700 to 800 millivolts and grow as you use it is because, like I said earlier, the hotter these capacitors are, the less effective they are at filtering DC voltage. So from a cold boot, you're going to see more DC being filtered and less DC offset going into your woofer compared to after running it for a few minutes and with it powered on when it's warmed everything up. Where did I learn all these things? Well, let's see. So depends on which all things you're talking about. If you're talking about the DC offset, so there's this other YouTuber, his name is Me Nick. He's the guy who basically figured out an effective way of disassembling the HomePods without breaking them. He also was the guy who made the YouTube video first talking about and discovering the source of the popping sound that HomePods were experiencing. At the time, nobody had associated death farts with the popping symptoms. The popping is like an early sign of these capacitors starting to go bad. So at the time, he and many others had thought that it was actually a different component on the board that was going bad and causing these popping sounds. And at the time, we also thought there was no replacement for this chip that people were blaming was the source of these issues. So, what I did was I took what we knew as a fact, right? He connected, just like we do here. He connected a multimeter in DC mode to a subwoofer connected to a HomePod, and he observed DC voltage going into the subwoofer from the HomePod amplifier. And that is in the audio industry, that is a pretty well-known thing that you don't want to have going into your speaker. Audio is an AC signal, not DC. It's an alternating current. It moves back and forth. It doesn't sit in a certain level and stay there. So how I basically learned most of this was I started with mostly just Google searches. I started looking up, what is DC offset? What is DC offset in amplifiers? Why is DC offset bad? I just started Googling all these questions. And then once I gained an understanding of what DC offset is and why it's bad for your speakers and your amplifier, then I looked and started trying to research where, potential sources for DC offset in audio amplifiers in general. Obviously, no one had done the work on the HomePod yet. So I was searching around just for, I would just do generic searches like DC offset in audio amplifier. And I would find various threads and forum posts from other people troubleshooting DC offset issues in their own homemade amplifiers or, manufactured amplifiers. Just trying to see if I could find any hints as to anything that I could maybe look at on the board itself for the HomePod to find the source of those that DC offset. The eureka moment really was when I came across this blog post from this random guy on the internet where he was talking about DC offset and its effects in audio amplifiers, how you filter it and such. And one thing that he said that stuck out to me was heat will make DC offset worse. So I thought, oh, well, if that's the case, can I just take my hot air gun with a small nozzle and slowly just move around the board until I suddenly see that DC offset spike? And then when I see that DC voltage spike, I'll know that that's the general area that the DC offset's actually coming from. And that's when I found the area that these four capacitors are. And once I found that, I took a plastic spudger and I would heat the spudger up. And then I would poke all these tiny little different components around here until, again, I was able to pinpoint exactly on the board which components that I heated up with my plastic tool caused the DC voltage reading to spike the most. And it pointed straight to these capacitors. The other key thing here that helped me in figuring this out was looking up the data sheet for the chip that they use to amplify the subwoofer. So the data sheet for the chip that they use for the amplifier happens to reference an evaluation board where the schematics are freely available. The chip on here that's actually responsible for amplifying the audio signal for the subwoofer is manufactured by Pal Raudio. And they didn't just manufacture this chip, but they also made a whole board, like just a standalone, like just evaluation board is what they call it in the industry. And the idea with these evaluation boards is you buy the board and you play around with it and you see if the product that they're essentially trying to sell you, that you're trying to evaluate, that chip, you're trying to see if it's going to work for what you want to do using that board instead of building a whole amplifier from scratch. However, they give you schematics for that evaluation board too, in the off chance you just want to build the board yourself. So, you know, I was able to figure out the component that was causing the DC offset, but I needed to figure out what it was, like its value in specification, in order to replace it. Because there's many different values and voltage ratings and tolerances that these capacitors come in. You can't just slap some new ones on that look the same, and it might work, but more likely than not, it's going to cause issues again. So, looking at the data sheet for the evaluation board for the chip that Apple used for the HomePod amplifier, I was able to find the value in the specification of the filtering capacitors that Pal Raudio recommended to use for their specific amplifier chip. With those two pieces of information, which capacitors they use to filter the offset in their evaluation board, and where those parts are on the HomePod amp, that was it. I figured I was able to order some replacement capacitors online in the exact specification that Pal Raudio used in their evaluation board, replaced them, and I saw exactly what you see here in most of our repairs. We saw a drastic decrease in the DC voltage that gets sent to the subwoofer, and we got rid of death farts. That it doesn't go without saying. It wasn't as straightforward of a path for me to get to this point as just all of that. I spent a really, really long time and broke a lot of amplifiers. At first, before I dug into the Google searches and understanding DC offset and audio amplifiers, I just tried brute forcing the problem by replacing every single part on the board here. But once I got about halfway through, I started realizing how impractical that was really gonna be. There's a lot of really tiny components on here, and well, we already knew the general area that the bass amplification circuit lives on the board. There was still way too much for me to reliably and effectively replace all of the components with a known working board in order to find that. So that's when I went down the use your brain route and solved it the way that I explained. So that's how I learned all those things, and that's how I figured out the death fart problem. I didn't go to college. I haven't taken any online courses. I just do a bunch of Google searches and watch YouTube videos. And then I practice a lot on my own. And then once I got confident, you should work for iFixit. I would love to work for iFixit. That would be cool. That would be so cool. Only if they would let me continue fixing HomePods, or if they themselves perhaps offered HomePod repair services and let me work on them for them. I would be totally down for that. But like I said earlier, one of my main things is keeping this at a like an affordable, a reasonable price, right? I could very easily justify and charge well over $120 for repairs. Still end up being a little cheaper than, you know, buying a replacement from Apple outright. But it does not, that does not sit right with me. Like, people already spent so much money on these speakers. There's no good reason for me to gouge them more than they already have been. Google's the biggest school. Pretty much, man. Okay, maybe not specifically Google, but just the internet in general. The internet is the biggest school. Well, but I guess I pretty much exclusively used Google and YouTube to figure most of this stuff out, so. I guess it's Google. No, it's not Google, actually. It's Alphabet. Gotta remember that. The parent company. Because they own Google, YouTube, and whatever else. Such a funny name, oh my god. Alphabet. Oh boy. Alright, off the table, pry. Hey! Alright, before we do any repairs on this board, let's go ahead and do some basic diagnostics here. We're going to put some spare parts on here so that we can power it on before we do any changes or repairs to it. Get a rough idea of exactly how much DC offset this amplifier is currently spitting out. And then we can do our repairs and compare the before and after results to confirm that we've likely got the issue fixed. Alright, let's see what she's got here. I'm going to go ahead and jump the meter up to the 20 volt scale here. 20 volt DC scale. It goes from 200 millivolts to 2 volts to 20 volts for the DC scale on this multimeter. So 200 millivolts is obviously going to be far too low for most likely what this has. Let's find out. Yeah, so we've got 600 millivolts of DC offset. I guessed it, spot on pretty much, and it's gonna creep up here to 700, probably 8 or 900 in the next few seconds. I bet you I can get this to fart on command for us here. Y'all want to see that? Check out these cool moves. We've got our heat gun here, and if we point this right at those caps, oh, that always scares me. And there it goes, it restarts. So once the amplifier sees about 2 to 3 volts DC going to the subwoofer, it forces a restart, presumably in an attempt to allow itself to maybe cool down. In any case, I think that death fart behavior is actually programmed into either the amp IC chip or the DAC chip itself. That's not anywhere else, because I remember reading in the data sheet for one of those two chips that it's got that behavior built in. So there you go. There's a death fart on demand for you there. And when we wake the amplifier back up, we're already up at 1.1 volts. If we sit here for a few minutes, I'm sure naturally this would continue to creep up to our... That's a spam call. Stop wasting my time. I'm sure this would creep up to that 2 to 3 volt threshold and fart on us again. But we're not going to wait for that. Wow, what a pop. Let's get it fixed. Yeah, I was reading the data sheet for, it was either the AMP IC or the DAC IC, one of those two chips, and it mentioned automatic DC bias sensing and recovery, where like past a certain threshold it would just power off and back on again essentially, and produce that tone. So now you know. Now you've seen it. Live flatulence. Let's get those capacitors replaced and see if we can improve that situation. That should do it. Oh, bullocks. Is that gonna do what I want it to do? No. That's okay. Those are looking like some solid connections on there. I know you guys can't see it too well, but alright, like I said before, with all of our repairs, regardless of what they're coming in for, we replace that 60 volt 5 amp Schottky barrier diode that loves to short itself out and cause no power issues. We're going to go ahead and get that replaced while we've got this apart, so hopefully they shouldn't have to worry about that for a long time coming, if ever. And just to be clear, this diode has nothing to do with death farts or DC offset issues. This is purely preventative, purely a preventative thing that we do with our repairs here. Just because we don't really know for certain what causes this diode to go bad. Our best guess, like I said, is probably a bad batch, but we just don't have the data to really prove that. So the cost of the component and my time to replace that every time is negligible compared to otherwise. No comparison. And like, we've already done all the hard work and the most time taking it apart, we might as well. I know most repair shops don't work like that. They fix the one and only thing that you sent it in for, and they don't touch or mess with anything else. And that's totally fine. But I am making the choice, the completely harmless and possibly the right choice here, to replace this diode for every single HomePod that comes in that we take apart. regardless of its issue. Just because we see this diode fail so damn often. And again, only Apple really knows for sure why this thing loves to short out. But if it's a bad batch issue or a longevity issue for this specific diode, this will go a long way for a lot of people. Beautiful. Okay. We just want to give this a minute to cool down here real fast. We don't want that heat messing with our DC offset reading here. Okay. And bullocks. Go ahead and bump that meter down to the 200 millivolt scale, since I'm fairly confident we've got our DC offset under control here now. And power this on. And the verdict is... yeah! Look at that. Oh, 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 yeah! That's what I'm talking about. Yeah! No more popping, no more farting. Let's get this put back together, and we'll be all done for the day. I'm gonna be done in like 5 or 10 minutes. Alright, so that's about as much as we're going to put this one together for now. Eddie has requested that we dye his mesh purple color. So I actually had to order the color that he wanted online. I couldn't find it anywhere locally, so I had to place an order for that online, and it's going to show up here tomorrow. So I'm not going to bother putting this the rest of the way together because I'm going to need to just take this mesh right back off again. I'm going to keep it on the HomePod until then because I don't want the mesh to deform in any way while it sits and waits for its coloring to be done. But we will go ahead and connect our logic board and display really fast just to make sure that this is all put back together nice and proper. And that there aren't any other unexpected issues with this HomePod. He did buy this, I believe he did buy this used in broken condition straight from eBay and had it sent right to me, so we don't really know its history, but let's find out. Alright, so everything in this HomePod seems to work. We'll just let it boot up here real quick and check it for sound, and we'll be all done. Alright, and I think it's working. I can't tell because they probably have Siri disabled on here. And it's not going to play any music because it's not connected to any Wi-Fi. Alright, well it seems to be working aside from that. We'll go ahead and get that unplugged from power. And that's all that we have for today here actually. So hope you guys all enjoyed this fairly lengthy live stream repair here. If you have any questions about any of the repairs that I've done, or doing your own repairs, I've got quite a bit of information on my website at nixfix.com. It's got a lot of the repairs that I've done here on the channel and all of the part numbers and parts that I use for my repairs. So if you're wondering what diode or capacitor I'm using, I've got all those part numbers and information up on my website. If instead you'd rather send it in for repair here on the channel, I've got my contact info also on my website. Check it out sometime. It's a pretty cool website. In any case, that's it for today, and I'll catch you all in the next one. Goodbye.